Good morning, afternoon, everyone. What we're going to do today is work on variables separable, how to solve them. So this is my first example for today. The derivative du by dt is equal to this. If you look carefully at this fraction, it is not separated. Shouldn't there be t's on the top and u's on the bottom? And we don't have that. Agreed? So we have to figure out how we're going to make this more like f of t over g of u. If you look at that question, this fraction, if you look at the bottom in particular, is there anything that I can do to help it out?
Do you multiply both sides by 1 in the form of t squared over t squared?
Wouldn't, not t squared over t squared, although I kind of get a feel for what you're thinking about. Let's just focus on, can you see any common factors here? That might be a better approach. Can you see something that you can do with ut squared plus u to the 4t squared? So let's factor out the t squared. Now that might indirectly end up being sort of what you're talking about, and put a little bracket around that. But what I'm going to do is that. Now, do you see this t squared on the bottom? Can't you move it to the top? But if you do that, it turns into t to the power of -2. You've seen that little algebra trick before. Now, what I can then do is just distribute the t to the -2. Now, would you agree we've now got the nice variable separable? So now we can do the crossover thing, which looks like this. And power rule. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, give this a plus c. The only thing I could really reasonably expect to do to this is maybe call that this, but even that I'm not 100% sure there's much benefit. Would you agree that this guy, you cannot do it as a u equals? And the main reason I can tell that is, do you see how there's two distinct terms with u in them? If you see one variable, right, just one u or one y or one whatever the letter is variable, you've got a chance to convert it into the y equals format. But this is the answer. That's as good as we can do. It's an implicit formula, but it's still correct. Are we good with that one? Right, you had a bit of algebra at the beginning, which kind of slowed things down, but after that, it went pretty smoothly. So this next one doesn't even vaguely look like a variable separable. So it's typical in these kinds of questions that we have to fix it so that it does look like this fraction format. What should I do to both sides to get it closer to what I need it to be? What should I do to both sides?
Subtract 6e to the t plus z. I think that's it.
Correct. Agreed? Now, I know I need a fraction. There's no way around that. I need a fraction. And this guy is causing me trouble. Do you know that e to the power of t plus z can also be written as e to the t times e to the z? Right, that's allowed, right? And if you think of it like that, can you see you can now separate them? Are you comfortable about e to the t plus c? It's a bit like what? E to the power of a plus b can be written as e to the a times e to the b. It's that property that I'm using. Now we are in the right format. We can do the crossover trick on this side and on that side. If you integrate e to the negative z, you do get e to the negative z, but you also get a negative, right, when you integrate. And if you integrate e to the t, you pretty much don't get anything except what you started with, plus a c. Now, can this guy be rewritten as a z equals? I'm going to multiply both sides by -1. And although it hurts me to do this, to keep WebAssign happy, I'm going to call it -c, because that's what WebAssign does. Right? I just don't want to make your life difficult. But really, I would prefer, if I was in charge, to make that plus c. Okay, now you need to tell me how to get to the next level. I'm trying to get z on its own, and this is where we are. What can I do to both
Take
sides?
the
Natural log.
I hear you. And the natural log gets you this, and the natural log of that is just the whole thing, including that. And so z will be negative the natural log of this. And that's that one finished. There is a kind of flow, isn't there? There's a process to how you do these questions. If you need to, put them into the format that is variable separable. Do the crossover. Integrate each piece, and then depends what you get. Sometimes when you've integrated, you're finished, right? The answer's just there. But if there's only one z, like here, you should be able to, with whatever it is, 3-4 lines of working, turn it into a z equals format. And that's the end of that one. Not that dissimilar, maybe even a little bit easier than the one we just finished, number 5. Right, this has to be a fraction. Who goes on the top?
6x.
Now, what's that guy going to look like when he goes in the bottom?
e to the -1.
Okay, well, we're cool about getting it in its right format, right? The variable separable format. Now I'll do the crossover. You integrate e to the -y, you get this. You do a power rule on this, you get that. Can we take this guy and make him a y equals? Agree? You see there's only one y again, right? We can do it. Not unlike the previous question. Multiply everybody by -1, and to keep WebAssign happy, -c. Take the natural log of both sides. You can either say divide both sides by -1, or you can say multiply both sides by -1. It essentially ends up being the same thing. You've got that. But now we have something extra to do. In this question, we call these guys the general solution to a differential equation, right? It's general because there's a C, and that C could be different values. But in this question, you're given a boundary condition, y of 0 is 0. So they are telling us that when x is 0, y is 0. So I'm going to go here and I'm going to make y 0. That's just basically 0. And I get that. Ooh, that's a cool one. You might just be able to look at that and tell me that you know what C is, but it's not particularly obvious what number C is. Anybody actually have a good guess at it? What do you think C is going to be? What number? 1? I agree. It's going to be 1. What kind of 1? Plus or minus?
-1.
Yeah.
Is it? Yeah.
Yeah, -1. Right. But let's just kind of do the math of it. Would you agree that dividing both sides by -1, that's true? If you raise each one to the power of e, you get 1, right? And this guy is -c. And that's where the -1 came from. And now I'm about to show you something that people do wrong. And it's why I dislike -c. Oh, c is -1, -1 goes there. It's wrong. Do you notice that this formula has -c?
Yeah. So they're forgetting that, you know, negative times negative would equal positive. So
Yeah. Do you see why I dislike the -c arbitrary constant? Because it is so easy for you to just not even notice that it's there in the answer. And then typically what happens is you get a plus where a minus should go, or a minus where a plus should go. But we are now finished. So we've moved from just solving a differential equations variable separable to solving ones that have initial or boundary conditions. This is du by dt 2t plus secant squared t over 2u. And this one has a boundary condition of that. And we won't use that till later. I'll start off with the first question. Is this guy good to go? Is he already separated out the way it needs to be? Agreed? So let's see what we get next then. 2u du is equal to 2t secant squared t dt. Power rule. That was easy. Power rule. Okay, what is the antiderivative, or if you prefer the word integral, of secant squared? Would it be?
tan?
It is indeed.
I have to look at my reference notes.
Yeah. I can understand why you should. It's better if you can memorize it. It just saves you a whole load of time. But it is in your notes. You can find it. Would you agree that this guy can be turned into a u easily? In fact, it's a one-line deal. And we're going to make an assumption here that it's the positive answer that we're looking for. And if all you were being asked to do is solve that as a general solution, this is finished. But let's do this fella here. When x is 0, u is 4. That's -4. So I'm going to change my mind. Since you've told me that, isn't the initial condition that that needs to be negative? How do I know that it has to be negative based on what they just told me up here?
Because the negative can't be inside of the
Square root, and it has to be an outside because this is -4. Jumping on top of your explanation. Yes. So this is -4, and it's negative nothing squared, which is nothing, plus a tan of nothing, which is nothing, plus c. Probably don't need this line, but I'm doing it anyway. Okay, what do you need to do to both sides to get c? Because there's two things you might do, but only one of them is right.
Square it.
And the answer is 16. So we have u equals negative the square root of t squared plus tan t plus 16. And that is the answer that they're looking for. I'm about to do one of my own, so it's not a homework question. Doesn't that look like it's variable separable? Look again. There's something wrong with it. Aren't the x's and the y's in the wrong place? And I can't just ignore the fact that they're in the wrong place, right? I have to fix it. Agreed? Okay, so what should I now write on the top?
X to -1.
Okay. And would you agree y to -1? You know, if it was y cubed over x cubed, a lot of people would find that easier to deal with, right? But isn't y just y to the 1? We don't normally write the 1, but that's what's there. Now, when we do the crossover, there's something else about to happen. So I deliberately picked this one because it looks simple, but it's just awkward all the way through. You cannot use the power rule on y to the -1. Because if you add 1 to the power, you get 0, but then you have to divide by that new power. And the reason is that it's a special case. So I have to remember that in this particular special case, don't have to think about it as 1 over x and 1 over y. Now, this fella is a natural log, and this fella is a natural log plus c. Agreed? This guy, natural log, this guy, natural log. Right, there's only one fella there. How will I be able to get y equals?
Would you put both sides in the exponent of e?
Yeah. I told you this question all the way through is going to cause you trouble. It's just awkward. Everything's awkward about it. This guy is y. Technically speaking, that is where we are right now. Okay. But I'm going to do that. So e to the log x plus c can be written as e to the log x times e to the c, right? Two things added can be separated out in this way. And now I get an x times e to the c. Do you see that the solution is just y equals e to the power of cx. A little ugly, agreed? A little awkward? But that's the best version. Would you agree that's a cleaner answer than that? Maybe you won't agree with me, but I would say it is. It's a little bit nicer. Are we good with that one? No. Next question is a version of question 9. And I'll write it down so I don't need to jump in and out all the time. Find the equation of a curve that passes through the point 0, 4 and whose slope is x over y. So this would be a very, very simple beginning to modeling using differential equations. Now, this bit of the phrase here is where the differential equation lives. Isn't the slope just another word for the derivative, right? The slope of a tangent line is its derivative. So this is telling us that the slope of the line is equal to that guy. And isn't this basically our boundary condition? So what was in words has now been transferred into a differential equation, a variable separable one, with a known boundary condition. The good news is, isn't this one okay? And darn it in space, let's try that again. Isn't this one variable separable, but they're in the right place? Now, 1/2 y squared is 1/2 x squared plus c. Are we good? Okay, can I turn this into y equals? Now, let's see what it looks like. If you multiply everybody by 2, you get that. And just to keep WebAssign happy, I'm going to leave it as 2z. And to get y, technically speaking, it should be a plus or minus. But I'm going to pick the plus, and I think this time I'm right. You see how it's a positive 4. So I'm going to use this boundary condition, that y is 4 when x is 0. If you square both sides, and then you divide, you get that. And then you go back to the original and you replace this c here, and that's why that becomes 16. So I'm saying that this curve passes through the point 0, 4, and its slope is x over y. Are we good? Let's do another application. Can you remember 141 population models called exponential growth? You remember those guys? You might get a formula that looks like this. The population at times t of a small village looks like that. You remember? those kind of guys. And then you'd get questions. It typically is almost guaranteed to be the last thing or one of the last things that you do in 141, right? Population models called exponential growth models. In this particular story, the population at the beginning was 200 people. And that 0.5 is called the growth rate. And as a decimal, it's that, but it's 2. So what you might get is, there's a small town in a desert with an initial population of 200 people. It has a growth rate, or a relative growth rate, I think it's the full name. It has a growth rate of 10%. Find a model that will represent the population of this town in T years from now. And that would be the answer. I'm going to create this formula from scratch. In other words, we're going to create an exponential growth model. So this piece of information that says it grows by 10%, it means 10% of the people. What that's saying is that the increase, right, the rate of growth, which is that, is 10% of the population. So I now have my differential equation. And if the population started off at 200, don't I have my initial or boundary condition as well? So when I end up solving that, we're going to get this guy here. Well, let's see how it works. I need a fraction. I don't have one. I have to make one. Now, should the P be on the top or the bottom?
The bottom.
And we've seen this before. Is it okay for me to say 0.1 on the top and P to the -1 on the bottom? Okay. Have we separated them out the way we need to? Yes. You might say, well, what about the T on the top? Well, you can actually have anything on your top as long as it's T or a number. And so in this case, it just happens to be a number. So it's allowed. So when we do the crossover, okay, so it still works. And this has happened before. You can't do the power rule on it. So I'm rewriting it like this so that I can call it the log of P. This guy is 0.1 T plus C. Are we good so far? Comfortable? Right. We've dealt with logs a couple of times now. Is it okay for me just to jump right into that line without putting the middle line in? E to the power of this equals e to the power of this. E to the power of a log just gets you P. That's how you essentially get rid of it. We're comfortable so far? Right. That's the general solution. So let's do this piece of information now. That's telling me that when T is 0, the population is 200. So 200 goes here. E to the nothing plus C. I guess that's 200 is equal to E to the C. How do you find C? What do you do to both sides now?
Natural log.
It's not the prettiest looking value C, but it is correct. So our solution now is P equals 0.1 T plus C. And you might say, but that doesn't look like this answer. It's kind of like it, but it's not quite. Well, let me make it look like it. Can't we separate them out into two? This guy times that guy. What does e to the power of natural log of 200 equal?
200.
So what we now have is that. So can you see that the exponential model actually grew from a differential equation, where you only told me two things: that the population increases at a rate of 10% a year, right? 0.1 times p, 10% a year. And that the initial population in this case was 200. And yet from just those two pieces, we created a formula that will tell you the population at any given time. Now, you could do population models that are much more complicated than that. And here's an example of a population model, which is an adaptation of this. What this population model would be saying is that the increase or otherwise of the population is 10% minus 20. This would be a model where the town had 20 people leave every year, right? They go to California. So you have 10% as the babies, right? But then 20 people leave. Now, if you solve this, wouldn't you have a different formula? And it would be a formula that would factor in not just the birth rate, but the others. To give you an example of a very simple version of that, we take two countries, Scotland and the United States of America. The growth rate of both countries is not the same. It's smaller in Scotland than it is in America, but that's because there's a lot more older people in Scotland. But the population of Scotland has remained very stable for about over 100 years. It's been 5 million. And the reason why it's 5 million and why the population of America is what, about 317, 330, something like that. The difference is in Scotland, we have a negative population difference between people who come and emigrate to Scotland and those who emigrate away from Scotland. In other words, I'm one of them, right? People leave Scotland and go other places. Some people, there are some, right, who come from other countries and come to Scotland, but the number who leave is much bigger. So it's like a minus 2, it's like a minus 20,000. So we might make 20,000 babies, but if 20,000 people leave, doesn't the population stay at 5 million? Right. And we're talking about a net growth rate. So when you have a 3% population growth, it means you have a 4% birth rate and maybe a 1% death rate, right? The net effect is 3%. And that's why Scotland's pretty much stayed the same. America, for instance, is growing because of population growth, right? People having babies. And it's also growing because of immigration, right? People coming to America. I'm one of them, right? And the net effect of that is that America population, Scotland's population kind of does this. Doesn't really move, 5 million all the time. Totally different scale, of course. America's population goes like that. In 100 years from now, there will be more Americans in America than there is today, right? 100 years from now, you'll be lucky if there's 6 million Scots people. Now, what does that have an effect on? It has a big effect on all sorts of things. Scotland's population, because it is fixed, there isn't a great deal of expansion going on. Cities don't get bigger. They don't need to, right? They're going to have the same number of people in them 50 years from now as they have right now. So you don't see a great deal. You do see buildings because things fall down and get old, right? And they knock them down. But it's kind of, if you knock down 100 houses, you just need to build 100 houses, right? It's kind of stable. And so you don't really need extra land. You don't really need extra anything, because as long as you're doing what you're doing, you're good. America, on the other hand, don't you have to keep building houses? More than you've got, because isn't next year there going to be 2 million more Americans than there are today? So you've got a bigger problem than Scotland as far as growth. Eventually, every country reaches its capacity level. I've got to tell you a story because it's in my head now. And when people say to you, how did you get to America? The answer is quite simple. I married an American woman. And the commute was killing us. It's a joke. So when we first married, my wife emigrated to Scotland, which is kind of interesting because most people emigrate the other way, right? But she emigrated to Scotland, and my parents weren't, so I could be with my parents. Their health wasn't great. So she came in. My wife emigrating to Scotland was a totally different experience from me emigrating to America. So I'll give you a kind of shortened version of it. My wife came over. I had a house. I had a job. She came over. Basically, she arrived at, I think it was Heathrow Airport. I can't remember now. She arrived at the airport. And she goes in and she meets this, it's like a nurse. And the nurse asked her some questions like, do you have TV? And do you have this? And do you have that? And she just said no. And then half an hour later, my wife came out and she was in. That was it. Pretty simple. And so I had to, later on, parent passed away, and we had to move back to America because our parents weren't keeping too well. And I had to go through the process of getting to America. So give you an example of some of the things I had to do. My wife had to have a job and a place to live. And she had to prove that she had enough money that if I was a has-been and didn't want to work, she could support 2 people. So I wouldn't be a strain on the American society, which is understandable. I had to go through what I can only describe as do you know if you do a military checkup where they poke you and prod you and stick every part of your body? Can you imagine I did one of them, but 10 times worse? I got an X-ray, I got blood samples, I got, you name it, they poked it, prodded it, or stuck something in it, right? I got the whole deal. And I passed, obviously. And they gave me a big X-ray. And I had to prove, for instance, that I don't have a criminal record. Now, do you know how you prove that you don't have something? It's really difficult. I mean, it's easy to prove you've got a criminal record. Couldn't you say I spent 5 years in, Berlin prison, and here's my thing that I've just come out, right? Or I get 4 years for vandalism or something. Anyway, you can actually do it. You fill in a form and you send it down to Scotland Yard, and they give you this piece of paper with your name and all your relevant information. And at the bottom it says this person has no criminal record. So that was another hurdle I had to get through. I had to prove that I didn't leave my job under unsuitable circumstances. So because I was a teacher, I had to go and check with the people who hired me in my school and then the district that there weren't any outstanding issues, inverted commas, which there wasn't, of course. And I did that and I got all that done. And it took me about 6 months. And I finally get to go to America at the end of all that. And so I arrive in the airport and I get in and I'm waiting to do my processing. Oh, by the way, see when you do this, do you know all they give you? A stinking little piece of paper that size that had a stamp on it that you put in your passport. I could have forged the bloody thing if I knew it was that easy. Right, anyway, they gave me this little piece of paper and I get to the, it was SeaTac Airport I flew into, and I get there and I show them my passport and I show them that little thing inside it. And I had with me all the time my X-ray because I thought this was important because they handed it to me. And I give the guy my X-ray and he looked at it and says, "What's that?" And I said, "It's my X-ray. I guess you want to look at it." I said, "I don't want to see it." And so I took it back. And they gave me another little bloody paper stamp that they put in your passport, which again I could have forged and I was in. But to this day, I still keep that X-ray because I figure out they're going to wait till about 30 years in. And then they say, "Have you got your X-ray?" And I'm going to say, "Yep, I've got one. See, here." The alternate was something I could have done, but I chose not to because I'm not that kind of person. When we get married, which was in America, I could have just stayed. Right? I was married to an American citizen. But if I'd stayed, that would have been illegal. And I don't like doing illegal things. So I did it the other way. And just to compare things. So if you want to emigrate to Scotland, it'll be pretty easy. And since you already live here, I don't think you want to emigrate to America. Oh, and I've drifted, as I do. Okay, let's finish.
Did you lose your Scottish citizenship, or were you able to keep both?
I don't have an American citizenship. I'm what's called a permanent resident. So I'm not an American citizen. Okay, our last one for today. This is going to be like question 11. Actually, I'm not going to do this one. I will do it for you in a minute. No help, no clues, no nothing. 3 minutes, solve it. Go for it. For those who need a little kind of shove to get started, there's a couple of lines to help you. There's no rush, but you've got 15 seconds. Okay, if you haven't, you can catch up with us. This is not a fraction, agreed? We've seen this problem before. Would you agree T's are on the top and P's have to be in the bottom? So I hope that you did that. Agreed? Now you do the crossover. Power rule. Well, if you add 1 to the power and then divide by the new power, you get that. If you add 1 to the power, oh, darn it in space. Okay, so 2/3. What's that going to get me? 14/3 plus C. Is that right? Okay. Not a lot I can do to this, but I should try my best to make it as nice as possible. So I will divide everybody by 2, which gets me 7/3. I guess to keep WebAssign happy, I'll call it a half C. If it helps for the next line, think of that as a square root. So what do I do to both sides to get P?
Square it.
Okay. So your final general solution would look something like this. And like 3/2, although it is correct, I would call it something like that, right? And we are now going to use the boundary condition that when T is 1, P is 2. So what have I got? I have got P is 1. Sorry, P is 2 when T is 1. So it's what, 7/3 plus a half C squared. That's the square root of 2. That's the square root of 2, take away 7/3, which makes C 2 lots of that, take away 14/3. So P is 7/3, this guy, plus a half C, and a half of this is just that guy above. And there is your ugly answer. Did you get that? Okay. Well, that is us finished variable separables. So you all say hi, and I'll hang about for any questions. When you turn up next week, we're going to look at how to solve a different kind of differential equation. These are called linear differential equations. So that's what we'll be doing next week. That'll probably take 2 days. And that gives us, what, 3 days to tidy up and revise for tests and finals and all that good stuff. Okay, bye-bye, guys. I shall see you on Monday. I'll hang about for any questions.
Have a good weekend. Thank you.
You too.
I had a quick question on homework.
Yes. Which one?
So it's problem 2, which seems like it should be easy, but it's not giving me.
What section?
This is the 9.3, the variable, just
Okay.
like this one.
And you're not getting their solution?
Yeah. So the question is dy over dx equals 7x times square root of y. And
You have a 7, right?
yeah,
Okay.
7.
X square root of y. Gotcha. Right.
So that should be 7x over y to the -1/2, right?
Nothing wrong with that. You did that right.
And then if you find the integrals of both, it should be 2y to the 1/2 equals 7/2 x to x squared, right?
Agreed. 7/2 x squared plus a c, of course.
Let's see. Yeah.
Okay.
Oh yeah, and then yeah, plus c.
Okay.
So I'm just kind of doing it as I'm going because I lost what I did it on my work.
So
And then
basically,
divide by
if
2.
you divide by 2 and call that square root while we're at it, what do you get? 7/4 x squared plus a half c,
Yeah.
and then you would square both sides.
Oh,
Do you see what's wrong?
I see where I went wrong. I think instead of dividing by 2, I multiplied by 2 for some reason.
Oh, okay.
So
Well,
I
that
think
might have
that's it.
fixed it.
Yeah.
Okay.
Okay, that's all.
I'm looking at their solution, and oh, they're annoying.
Are they keeping c in there where they do like the?
Yeah, they made it
Okay.
C this time. So they're not even consistent themselves. So watch that. You know, if it's a minus C and it doesn't work, just try plus C. If it's a half C and it doesn't work, try plus C again, right? Yeah, I if they're going to do what they want to do, they should keep doing it all the time, shouldn't they? They should just be consistent and always do whatever it is they've decided is the right thing. The worst thing you can do is change the rules halfway through the football game, right? It's not a good idea. Yeah, that was annoying. Any other questions?
I have kind of a super basic question.
I like super basic. I'll probably give you a stupid answer, but go for it.
That's all I really need. So today when you're showing us, I think it was, let me find it really fast. Got a lot of notes here. Oh, it was, yeah, just dy dx equals x over y. You did 1/2 y squared equals 1/2 x squared plus 2c. Why?
Well, eventually I did. There might have
Oh.
been something. So what we had before that was a line that looked something like this. And I'll just go through each one, make sure. Maybe I wrote something wrong. That's possible. No, anyway. There is a 2 coming in, and I'm pretty sure I know where it should come in, right? Then if you multiply both sides by 2, that sounds like what you're talking about. Oh, you can't see it.
I can't see it.
Right.
Oh, okay.
And-
Oh, gotcha. Okay, yeah, because I wrote it the way it was written down. The way I saw it was 1/2 y squared equals 1/2 x squared plus 2c, and so
Yeah, that happens the next line.
all right, yeah, that really messed me up, but I got it. Thank you so much.
Okay. Any other questions?
Yes, so just, oh, sorry, go ahead.
No, you can
Isabella?
go ahead. Okay. Number 9 on 9.1, I'm stuck on.
Is it something you can read out to me, or will I have to go looking for it?
You would have to go look for it. It's really
Ugly,
lots of
long.
parts.
Okay.
Yeah.
I mean, just takes a few moments for me to do all the window things. You think now I'd be good at Windows, but I'm absolutely useless at them. You know, I can't find the right window. So it's 9.1. Gotcha. And it was question what number again?
9 and part B.
9 from 9.1. All right.
Yeah.
Okay. And I'm going to put it on the screen to see if it's at least similar to the one you're talking about, because they always change the questions a little bit each time. Does it look some like here's 4 pictures?
Yeah, that's it.
Right, now it says match the differential equation with the solution, and they're called 1 to 4. Okay. And give a reason for each of your choices. So you were in trouble with this one, right?
Yeah.
Does it actually look like that one? Because it would be helpful if it did.
Yeah, it's the exact same.
Right. So let's see what it is. It's x e to the negative x squared plus y squared. And that's the slope of the thing has to equal this. So what I'm looking for is plus or minuses. That's really helpful. Because if I know the slope, the derivative is positive, then the curve is going uphill. But if I know it's negative, it's going downhill. So what I'm doing is I'm looking at this and I'm saying, do you see this ugly stuff here? All of this? It's
Yeah.
always positive. It's always positive. Right? Now, what that tells me is then that this thing here will be greater than or equal to 0 when x is greater than 0. And this derivative, right, will be less than or equal to 0 when x is less than 0. So this expression will have a positive answer, and therefore it's increasing. Only cares what x is. So if x is plus 2, it's positive. If x is negative 2, it's negative. Now, the only curve with positive negative tangent slopes when x is less than 0, and positive tangent slopes when x is 0, I would have switched those sentences around, is labeled. So let's see what picture. It has to be positive when x is plus and downhill when x is negative. Positive, 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 everybody's 0. The only one that is coming downhill, negative slopes when x is negative, and then positive going uphill when x is positive, is picture number 1. And that's how I decided that it was 1.